Hello, this is a video explaining electrostatics at GCSE level for physics. One of the more difficult sort of topics. Let's just get straight into it. So 4 things that we're going to be covering is, first of all, insulators can be charged by friction. Then we'll talk about the transfer of electrons. Then we're going to talk about like and unlike charges and how they exert forces on each other. And then we'll finish off with the applications and hazards of electrostatics. So insulators can be charged by friction. This is basically when two materials are rubbed together, they can become electrically charged. One will have a positive static charge and the other has an equal negative static charge. So for example, if in a question one material had a +3 charge, that means that the other one will have a -3 charge. They're equal but opposite, if that makes sense. So this is a good example that commonly comes up. When you rub a polythene rod with this cloth duster, the cloth becomes positively charged and the rod becomes negatively charged. However, if you change the material of a rod, all of a sudden the one that becomes positively charged switches and we've got a difference. So basically the one that becomes positively charged is determined by the materials themselves, is the important thing to take away from that. Now, the reason this happens is because the materials lose and gain electrons. So remember, electrons are negatively charged. Basically, when the two materials rub together, the electrons are scraped off one and dumped onto the other one. Which way the electrons are transferred depends on the two materials involved. And a really important thing to remember is that positive and negative electrostatic charges are caused by the movement of electrons, not protons. So protons never move. It's only the electrons that are ever transferred. And that's something they can sometimes sort of bring up to catch you out. And yeah, just remember, if an electron is negatively charged and it is removed from a material, that will cause the material to become more positively charged because you've taken away negative charge. However, if I add negative charge to a material, that's when it becomes more negatively charged. So they're the sort of concepts you've got to get around your head to sort of figure out what's happening in terms of the transfer of electrons and what effect that will have on the charge. Then we move on to like and unlike charges, repelling and attracting. So basically, if two charges are both negative or positive, they are going to repel each other. However, if they are opposite charges, they attract each other. That's sort of why like charges repel, unlike charges attract, basically. So they exert a force on each other. And these forces will get weaker the further they're apart. So they're most strongest when they're near each other, which I think is quite obvious. This is a non-contact force called electrostatic attraction and repulsion, and it can actually cause objects to move. And I actually have an example of this that I can quickly show in a video. So right here we've got this guy right here. He's using a rod, and this rod is positively charged, and as you can see, as he puts the rod up to this material, which is also positively charged, they are repelling each other. This is because, you know, like I just said, because they're both positively charged, they've got the same sort of charge, that means they're going to repel each other. However, when he brings the rod over to here, you can see him using the cloth to give it the positive charge. This one has a negative charge, meaning that now it's attracted to the rod. So that's kind of an explanation of how that works and how they move together. Let me just quickly get out of full screen now. Alright, so final thing is applications and hazards. So an electric charge will build on these objects, and that means the potential difference between the object and the earth, which is at 0 volts, increases. The important thing to note here is if the potential difference gets large enough, so enough charge builds up, the electrons can jump across the gap between the charged object and the earth. This causes a spark, and they can also jump to an earth conductor, which in this case can be yourself. So for example, if you're getting out a car, the car's metal frame is going to build an electrostatic charge due to the friction it has with other things, right? So when you get out, sometimes the electrostatic charge is so high in that car that when you leave the car and you touch it, the electrostatic charge travels through your body into the earth, basically. And that's why this can be very dangerous, because obviously high electrostatic charges, you know, they're the sort of things that can kill you, basically. And this usually happens when the gap is fairly small, but lightning is an example where it can happen over a massive area. That is what lightning is. There's so much positive or negative charge building up in the atmosphere that eventually it has to earth itself, so it sends down a massive electrostatic spark. But that's obviously a very big example. So now we'll move on to sort of an exam question. This is a very common sort of question, and it's very important to know how to word things. So in this case, Daniel S. removes his jumper in a dark room. As he does so, he sees tiny sparks of light between his jumper and shirt. Explain the cause of this. This is 3 marks. So basically, friction between the jumper and the shirt causes static charge to build on both. And remember to always explain why. This is due to the electrons being transferred from one item to the other. It doesn't matter which is to which. It might tell you that, it might not. And then the final thing is the potential difference becomes large enough for the electron to jump across the small gap between the jumper and shirt, causing sparks. So this is sort of an example of a question where they're not telling you anything to do with electrostatic attraction or repulsion or charges or any of that. Just by seeing sparks, and you're asked to explain why, and to do with friction as well. Think, when you take your jumper away, there's friction between it and the shirt, and that's what's going to cause the electrostatic charge. So that's about a 5-minute explanation of this topic. I hope that all made sense. Leave any questions below, and be sure to subscribe for more GCSE physics videos, and I'll see you later.